Greetings everyone, myself Janice Desai. Today I will be explaining satellite orbits, which are the specific path that satellites follow around the Earth. First of all, introduction to satellite orbits. These orbits exist because of the balance between the satellite's forward speed and Earth's gravitational pull. Different orbits are used for different purposes, such as communications, navigations, weather monitoring, broadcasting, and other scientific research. Each orbit has its own unique altitude, coverage area, and performance characteristics. The main, the main three types of orbits used today are LEO, which stands for Low Earth Orbit, then we have MEO, which stands for Medium Earth Orbit, and at last we have GEO, which stands for Geostationary Orbit. Understanding these orbits help us understand why certain satellites are used for internet services, other for GPS, and other for TV broadcasting. So, as in our diagram, this shows that how the orbit are placed within us a distance, and it is from how much far from the Earth. Then we have basics of orbital mechanics. So now we have to understand where to have our satellites. To understand satellite orbits, it's important to understand a few basics of orbital mechanics. A satellite stays in orbit because its forward velocity balances Earth's gravity, which prevents it from falling back to Earth. Important parameters include altitude, inclination, orbital period, and velocity. Higher orbits takes more time to complete one revolution, while lower orbits move faster. Orbits can be circular, and inclination determines whether a satellite covers the equator. Satellite lifetime, radiation exposure, and fuel usage all depends on the orbit they operate in. This all depends on the orbit. How we can say that the nearby have some other orbit, and the far from that have some other usage and fuel depends on its distance. Now we have low Earth orbits, our first satellite, and near to the Earth. So it is roughly about 160 to 2000 km above the Earth. Because LEO satellites are close to Earth, they provide very low latency, typically around 10 to 40 milliseconds. This makes them ideal for broadband internet service like Starlinks and other nets. LEO satellites move very quickly. They circle the Earth in about 90 to 120 minutes. Since they move across the sky rapidly, we need large constellations of many satellites to ensure continuous global coverage. LEO satellites are commonly used for Earth observation and remote sensing, scientific missions, and other environmental monitoring. Their low altitude also allows high resolution imaging, but atmospheric drag reduces their lifespan unless they are boosted periodically. Then we have medium Earth orbit, which is also known as MEO. MEO ranges from 2000 to 35,000 kilometers. The most common satellites found in MEO are navigation satellites such as GPS. These satellites typically operate around 20,000 km altitude, where they provide global positioning and timing service with high accuracy. MEO is a balance point between LEO and GEO. It lies between LEO and MEO. It offers it offers larger coverage than LEO. It has lower latency than GEO. Fewer satellites are needed compared to LEO constellations. However, signals still travel significant distance, so latency is moderate, higher than LEO but lower than GEO. MEO satellites are more expensive to deploy but have longer operational lifetime. Now we have geostationary orbit, which is also known as GEO. GEO is directly to 35,000 km above the equator. At this height, the satellite rotates at the same speed as Earth. So from the ground, the satellite appears stationary. This is extremely useful because ground antennas do not need to track the satellites. They point at the one spot continuously. GEO satellites provide coverage over almost one third of Earth's surface, making them ideal for TV broadcasting, telecom, weather forecasting, and other satellite communication networks. The major drawback of GEO is high latency, usually around 500 to 600 milliseconds, because signals have to travel a very long distance. Also, coverage weakness in high altitude and polar regions because GEO satellites sit above the equator. Then we have comparison between LEO, MEO, and GEO. Each orbit has its strengths and LEO offers low latency and high resolution imaging but requires more satellite, whereas MEO provides a good balance, fewer satellites than LEO and better latency than GEO. Geo provides Geo provides constant coverage and is perfect for broadcasting but suffers from high delay as it has to travel from distance. So we can say that LEO is ideal for broadband and MEO is best for navigation systems. And at last, Geo is used for communications. Now, what are the communication challenges which are faced in orbits? First of all, propagation delay, which are high in geo, as we know that propagation delay depends on the distance. The distance is more, the delay is more. So it is high in geo. Then we have weather effects, which is main concern for orbits and satellites. Especially it's in the rain fed, the signal becomes weaker. Then we have Doppler shift. It is the significance in LEO because satellites move very fast and we cannot communicate fastly with signals. So after this, ground stations decided to have advanced tracking system. Satellites also face issues like power limitations, thermal management, and other radiation exposures. To overcome all these challenges, techniques such as efficient modulations, we have adapting systems which fights with this issue. Then we have applications of satellite orbits. So different orbits support different applications. First of all, LEO supports Earth observations as it is near to the Earth. Then it supports surveillance and global internet. Then we have MEO, which supports GPS and navigation. Then at last we have GEO, which supports TV broadcasting, weather satellites and other satellites related works. Satellite also supports aviation navigations and has some of the parts with remote healthcare. As we all know that satellite we have to work with satellite in day to day life. We use satellite communication day to day life. Then in conclusion, we can say that LEO, MEO, and GEO orbits form a backbone of modern satellite communications. Each orbit offers unique advantages. LEO provides low latency, whereas MEO balances performance, and GEO offers continuous service. Understanding these orbital characteristics helps engineer design reliable system for communications, defense, and internet services. As satellite technology advances, these orbits will continue shaping the future of global connectivity. As we can know that nowadays the connection and automation is getting high, and so we can say that more and more connection to the satellite in the future will be there. So we will going to expand our. So we can say that in the future the global connectivity will be expanded and we will continuously be in touch with the satellites more than more when we more than nowadays. Thank you.